Hello everyone, we continue with the applications of logarithm. I want to introduce more and more applications of logarithm, so I'm sharing some word problems. And these are actually from uh, the past topics you have studied, maybe in grade 11, uh, with respect to exponential functions. So for 400 gram of a new radioactive element, the half-life is 5.2 years. How long would it take the element to decay to 125 grams? So this is a half-life kind of question. And we recall the formula for the half-life, which was m equals m sub 0 times 2 to the power of negative t over h. So m sub 0 is the initial amount of the radioactive element that you have. In this case, it's 400 grams actually. And m represents the remaining mass of the radioactive element after it decays. And T stands for time elapsed, and H stands for the half-life of the radioactive element. Half-life is actually the time period required for uh, uh, any radioactive substance to decay to half of its original mass. So if you have 1 kilogram, after half-life time passes by, you have only half a kilogram left, or 500 grams. If another half-life time passes by, then half of that 500 gram, which is 250 grams, will remain due to this decaying process. So the formula is from before, and the numbers are 400, that's the original mass. The remaining mass is 125 grams, and then we multiply this by 2 to the exponent of negative t over 5.2 years. So the half-life is given. We are not trying to calculate that. Half-life is 5.2 years. Okay, so here we need to use our calculators. Perhaps dividing both sides by 400 is a good idea. And we end up with 125 over 400 equals 2 times 2 to the exponent of negative t over 5.2. Reducing the fraction will give us 5 over 16 because top and bottom are both divisible by 25, logically speaking. So 5 over 16 equals 2 to the exponent of negative t over 5.2. So what you have in front of you is nothing but an exponential equation. In order to solve exponential equations, we need to take the logarithm of both sides. That was one of the techniques we have studied in the past. So I take log of 5 over 16 on the left. That's equal to log of 2 to the exponent of negative t over 5.2. So log of left side equals log of right side. Now, the exponent of the argument of the logarithm, according to the power law of logarithm, becomes a coefficient for the log itself. So negative t over 5.2 times log of 2 equals to log of this fraction 5 over 16. So from here, if you want to solve for t, I would say t equals negative 5.2 times log of 5 over 16, all divided by log of 2. We know how to solve the variable. I solved for the variable t by doing cross multiplication, and this is what we ended up with. Now all we need is, of course, a calculator to figure out what the answer will be in this case. I know you're looking at the negative sign most likely, and you're saying that there must be something wrong here because time cannot be negative. But you have to be wiser than that, because logarithm of 5 over 16, logarithm of a number less than 1 itself is negative. So that negative times this negative will make it positive, and nothing is wrong here. We will not end up with a negative answer for the time, and we're going to get a positive answer. So it's not difficult to try with the calculator. Negative 5.2 times the logarithm, which is common log, as per our decision, of 5 over 16, okay, inside the brackets. And we divide this by log, again, base 10 of course, 2, log of 2. And the answer is 8.73. So 8.73 years. The unit of measurement for T and H is both the same units. If H, the half-life is given in years, then T, the time has to be in years. That's it. So because it's a word problem, needless to say, even if I don't do it, you got to do it. You have to write the final closing statement or a paraphrase in your own words. So you're going to say that it would need 8.73 years to pass in order for 125 grams of this radioactive element to remain, or something, in that range. Next question, it's about business math. So this was, again, another example from physics or perhaps chemistry. This one is from the world of business. So we have seen so many applications of logarithm. Loudness of sound, pH in chemistry, pH scale, and then earthquake magnitudes on the Richter scale. And now we see other applications in chemistry, physics, and this one is in business, actually, in the world of finance. How long would it take for an investment of X dollars? We don't know how much the principal was, maybe like $1,000 or whatever, to triple. Triple means if you have $1,000, you want it to be $3,000. If you have $10,000, you want your money to grow to $30,000 in an account at a bank that offers an interest rate of 12% per annum, /A means per annum, compounded weekly. So we have to use the compound interest formula here. So we're going to say A equals P times 1 plus R over K to the exponent of KT. That's the formula studied before. One by one, I'm going to explain. A stands for final amount in your bank account. P stands for principal, initial amount of money in your bank account. R stands for annual rate of interest expressed as a decimal. T stands for number of years passed. K stands for number of compounding periods per year. And as you saw, every single letter in the formula, I described it for you. Now, in this question, we don't know what the principal is. We don't know if this person had $2,500 in his account or like $10 million in his account. We don't know. But whatever it was, X dollars, this X dollars is supposed to triple. So if the person has X dollars, then the triple, that amount will be 3 times X dollars, obviously. So we sort of know the relationship between the principal and the final amount in the account. And then we have 1 plus 0.12, because the interest rate is 12% offered at this bank, expressed as a decimal. And we divide it by 52 because the question says interest is compounded weekly. If it was compounded annually, the K would be 1. Compounded semi-annually, K is 2. Quarterly, K is 4. Monthly, K is 12. And then we have bi-monthly, K is 24. Bi-weekly, K is 26. And weekly, K is 52. And of course, if it's daily, which is not that practical, K will be 365. So the exponent is 52 times T. So that's the formula we end up with. We're doing business math here. Now, X and X cancel out each other because it's a non-zero value. It's not like you have $0 in the account. So you can divide both sides by X, which is non-zero. And you end up with 3 equals 1. So you have to, let me see if you have the calculator somewhere. Okay, so 1 plus 0.12 divided by 52, that is 1.0, I have to write this down, 1.002307692 raised to the exponent of 52t. Once again, we ended up with an exponential equation. How do you solve this complicated exponential equation without the use of logarithm? Of course, you can't. You have to use logarithm. So we're going to take the log of both sides, log of this number, and then 52t, which is the exponent, becomes the coefficient. So 52t, okay, times the logarithm of this number. I'm not rounding off this number because it's not my final answer. I always round off the very final answer. So from here, t, it will be log of 3 divided by 52, okay, and then times log of the number. Okay, so now we just need a calculator. So we're going to take the common log because the base is 10. That's what we chose. Common log of the answer. So I got log of this. I'm going to multiply that by 52. And then I'm going to put in the denominator and divide log of 3 by this result. So log of 3 divided by the result I end up with 9.16. So 9.16566, which of course we can round it off to 9.2, and it is going to be in years, obviously, because T stands for number of years. So it will take 9.2 years for this investment of X dollars, or maybe $1,000 or whatever amount that is, to triple, actually, okay, to triple. All right, so that's another example in business mathematics or the world of finance. Then we have another example here from biology. So chemistry, physics, finance, biology. As you see, mathematics is everywhere. Logarithm is everywhere. That's the message we want to indirectly deliver actually in these lectures, that mathematics is all around us. We have to appreciate it, we have to respect it, we have to learn it, we have to study it, and we have to apply it in our lives, period. A bacteria culture starts with 8,600 bacteria. After 10 hours, the estimated count is 258,000. What is the doubling period? The doubling period is that time interval that has to pass for the initial number of cells or bacteria in a culture to double, the initial amount. So the formula for this was, I believe you have studied this formula in the past. So n equals n sub 0, 2 to the exponent of t over d. Once again, I'm going to introduce every single letter in the formula. N stands for final number of bacteria in the culture, or final number of cells in a biology lab. N sub 0 is the initial number of cells or initial number of bacteria. T stands for time elapsed, and D stands for doubling period. Okay, so we know the final amount is 258,000, and initial number is 8,600. We're going to multiply this by 2 to the exponent of t over 10, because no, it's the other way. It is 10 over d, because 10 hours is the time that is given, okay, and the doubling period is the unknown in the denominator. Okay, so we can divide both sides by 8,600. So 258,000 divided by 8,600 equals 2 to the exponent of 10 over d. I believe if you divide them, you end up with 30, if I'm not mistaken. So 30 equals 2 to the exponent of 10 over d. Imagine if this 30 was 32, that would be 2 to the exponent of 5. And I could say, because here you have 2 to the exponent of 10 over d, I would say that the exponents should be equal to each other. 5 equals 10 over d. From there, d would be like actually 2. 10 divided by 2 is 5. So I would quickly find the answer without even using the logarithm. But unfortunately, this number here is not 32, and it cannot, I repeat, not be expressed as a power of 2. If this was 32, sure, it would be 2 to the exponent of 5. We could solve the exponential equation without the help of logarithm completely. But now, because it's 30, and 30 happens not to be a power of 2, therefore we have no choice rather than using logarithm. And that's exactly what I'm talking about here, applications of logarithm. So we take the log of both sides, normally common logarithm of both sides. You can take a log to any base you feel like it. And then we have 10 over d times log of 2 equals log of 30. And from there, d would be 10 log of 2 divided by log of 30. So if we use a calculator, perhaps we can find out the doubling period of this special bacteria in this culture, in this biology lab. So 10 times log of 2, that's the numerator, and we're going to divide this by log, again common logarithm, of 30 this time, and the answer is 2.037. 2.037. We can say it's about 2.04, and the unit of measurement is hours. So this means that just a little bit more than 2 hours is the doubling period of this bacteria, this special bacteria in this biology lab. So doubling period formula, applications in biology, compound interest formula, applications in finance and business, and half-life formula, applications in chemistry/physics. So other than these applications, we have seen more applications in the past: earthquake, loudness of sound, and pH scale in chemistry. So you see that logarithm is almost everywhere. Thank you for your attention, and keep practicing as always.